Paper 1, question 24. Bill works for a computer service center, blah blah blah. You end up with this table here, frequency table here. So 12 calls lasted between no time at all and 10 minutes. 15 calls lasted between 10 and 15 minutes. 13 between 15 and 20. 18 between 20 and 30. And 3 between 30 and 45. On the grid, draw a histogram to show this information. Now, generally, when people look at this, they think, oh wow, what an easy question, I'm just drawing a bar graph or just drawing a histogram, right? They jump in, draw some bars, 12 high, 15 high, 13 high, 18 high, 3 high, on to the next one. Unfortunately not. This one does have a clue in it in the sense that it tells you on the y-axis here that it wants something called frequency density. It doesn't want just these values, which at this point in time do refer to the frequency. So, although they have something to do with the question, they aren't the heights of the bars themselves. And the reason for that is, as I've highlighted here in colour, the classes that you are given, the 0 to 10, the 30 to 45, so on, they're all different widths. You can't draw a bar graph or a histogram when you have, a normal one anyway, when you have different widths of bars. They all have to be equal. Otherwise you end up with a bar chart or a histogram that doesn't look right, would be the best way to describe it, and it becomes biased in a way. The media can do this at times to manipulate statistics where you end up seeing a bar that maybe 4 or 5 times the size of another bar, but they're the same height, which means they represent the same frequency or the same number, but by looks it catches your eye. You're like, whoa, there's heaps of values there. It's not true, it's not an honest representation. So in order to do this, and considering they have different widths, what frequency density does is it almost takes an average of, say here we have 12 values that are between 0 and 10. It takes that 12 and it shares them amongst the 0 to 1, the 1 to 2, the 2 to 3. It basically breaks down this into 10 pieces because there is 10 values that are covered. This one, it breaks it down into 5 pieces because 5 are covered, breaks down into 5 pieces, breaks down into 10 pieces, breaks down to 45 pieces. Now what I'm talking about with pieces is the class width, or in other words, how wide each bar is. In this case, it's 10 wide, 5 wide, 5 wide, 10 wide, 15 wide. And like I said, it's breaking it down, it's sharing this frequency amongst the 10 individual bars that could be in there. It's sharing this 15 amongst the 5 equal bars that could have been there, 13 amongst 5, so on and so forth. Sharing just being a different word for division. In order to get this thing called frequency density, you take your frequencies and you divide them by your class width. So the number of calls here divided by the class width is going to give us frequency density. 12 divided by 10, 15 divided by 5, so on and so forth. So I end up with 1.2, 3, 2.6, 1.8, and 0.2. These guys are what are going to be the heights of your bars. So all you need to do now is draw a bar graph the way you usually would in terms of the widths. You're okay to have these unequal widths bars because the heights don't represent the frequency, the heights represent this. The area of each bar tells you about how many there actually was. So here I have already drawn in the vertical lines just to save time. The frequency density, the first one was 1.2. I'll use a different colour here. So the first bar looks like that. Frequency density, the second one is 3. So the bar looks like that. I'll add the other bit in a minute. The 15 to 21 has a frequency of 2.6, which is there. The 20 to 30 has a frequency density of 1.8. And the 30 to 45 has a frequency density of 0.2. So what you have there is a histogram where you have bars that are different widths, but it's the areas that themselves that tell you about how many were in it. So as you can see, hopefully, the values here that have the biggest area are, your eyes will catch between this bar here and this bar there. And if you look at the frequencies, this one is 15, this one is 18. If you were to actually figure out the area for this, 10 wide and 1.8 high, the area of that is 18. The area of this one is 15, the area of this one is 13, the area of that one is 12, and hopefully you can see that this is the smallest area, the area of that is 3, and that is a frequency density graph.